Alrighty, let's take a look at this example here. It's saying that now we have the same situation except the cross sections still perpendicular to the x, except now they're semicircles, okay? So the only thing that's changing is the area formula. So we still want to find the volume from, again, it's the same curve, so still from 0 to 2 of the area with respect to x dx because it's perpendicular to the x-axis. Now, we have semicircles, right? So now we're dealing with the area of a semicircle. Okay, so the way this differs here is, let me try and draw a little picture. You've got your base of a triangle, right? We still have that base. Okay. But instead now our cross sections are circles. So it's kind of hard to draw, but now our cross sections are circles, right? And so when I take a piece out here, a little cross section here, like this, okay, what it looks like is kind of something like this. Right? Where our cross sections that we're taking out are semicircles. Okay? So again, area of a semicircle is 1/2 pi r squared, right? Okay? Except, again, r isn't just r. R is half of this distance, right? It's this minus that, but half of it because we want the radius. So you could think of it as 1/2 the diameter, right? But it's 1/2 pi. Now instead of r, it's f of x, the top function, minus g of x divided by 2 because it's the radius. So it's f of x minus g of x divided by 2 because it's the radius. The diameter is f of x minus g of x, just like we did in that other example there. Okay. So if I write it all out again, it'll be all over 2. F of x is 1 minus x, right? Minus g of x, again, I'm going to distribute the negative. Okay, and then this is all squared, right? So when you do that simplification again, in the numerator, the f of x minus g of x simplifies to 2 minus x over 2, and then that's squared, okay? This right here is the area formula with respect to the semicircles with respect to x, okay? So now all I have to do is take this, right, and plug it in for here. Okay, so I'm going to do that on a separate sheet of paper. Okay, so we have our, it might be nice to simplify this out, but you don't have to. So maybe what I'll do is simplify this a little bit and say, well, this is just 2 minus x over 2 times 2 minus x over 2, right? This becomes 1/2 pi over 4, and we already multiplied that out before. That was 4 minus 4x plus x squared, okay? And I'm just simplifying here. I'm going to put the 4 times the 2 and get 1/8 pi times 4 minus 4x plus x squared. Okay. Now what's nice about that is now when I put it back in here into my area, when I integrate, it'll be a little bit easier because I'm integrating from 0 to 2 this. And if you notice, I've got these constants that I can just pull out to the front. Okay. And then we integrate. This becomes keep the constants. 4x minus, again, this simplifies eventually to 2x squared plus x cubed over 3. And we're integrating from 0 to 2. Okay. And again, we're doing the fundamental theorem of calculus, so f2 minus f0. Okay. And I'm not going to go through all of those steps, but your final answer should be pi over 3. Okay. One more example.